second. Waiting. Okay, welcome back everyone to our week number 4 in preparing for professional machine learning engineer certification. And my name is Anna Muzikina. I am Google Developer Group organizer. And today we have our key speaker, Mohammad Alamin, will provide us deeper into preparing models, diving deeper into machine learning, and help us to prepare that we successfully pass this exam and hold motivation. You are welcome.
Thank you, Anna, to present me here. Thank you, everyone who is joining today online session. Today, guys, I will go through it a 100 feet overview of overall certification journey and why these office hours so crucial for the entire certification journey. Then we will go through some sample question and diagnostics questions, and we will try to identify the gaps which we need to fill before the sit on the vital exam. And also we'll brief discussion about our study plan and tips and tricks of the certification exam. Today agenda, I will capture the capturing the training artifacts and workbench training environment, TensorFlow, and hyperparameter tunings. These five key points I will discuss today. Each of these keyword with feature advantage and when you should use and what purpose you need to use on your use case. Let us see this MLF option. The last week I have discussed about this MLF option and everything. You can check this previous uh, slide, a previous session that will be helpful to you when you decide the ML options and which use case you should use the BigQuery, when you use the AutoML, and when you use the Vertex AI for the custom trainings, you will find out the details. So I will direct go through it in the capturing the training artifacts session. There is advantage and others feature.
I
Let
have
us.
just one notification. I'm so sorry. Can you please move this pop up somewhere because
Oh,
it's
okay, okay, okay,
not
okay. Oh,
visible
sorry.
all
Yes,
title. Perfect.
yes. It
Thank
is
you.
okay now. It is okay now.
Perfect.
Yes, okay. Let us discuss about the best practice artifact organization. You can use the Git version control your ML pipeline and the custom components you build for those pipeline. Use artifact registry to store, manage, and secure your Docker container images without making them publicly visible. Let us break down the machine learning operational MLFs. In this machine learning MLFs operation, you can see this is the trainings, how many, this is the best practice of the artifact organization. You can check this slide, the source control repo as a storage location, the notebook pipeline source code and pre-processing function and model source code source code. So actually, what purpose you when you use the source code control repository, the source code control repository like the Git and central location for managing all code and script used in the MLOps pipeline. This is where the versioning and collaborating happen, ensuring the reproducible and auditable process. The notebook, these are often used for exponential data analysis, prototyping model, and initial experiment. They contain both code and documentation, making them valuable for research and development. And pipeline source code use, this is the source code that define the entire automated ML workflow. from data ingestion to the model development. It orchestrates the different steps of the pipeline. Preprocess function. This is the script and function responsible for cleaning, transforming, and preparing the raw data for model trainings. Model source code. This is the code for actually machine learning, model architecturing, and its training the logic. We are talking the source control repo as a storage caution for the artifact organization best practice. When you use the why you use the notebook, and when you use the pipeline source code and pre-processing function and model source codes. Experiment, if you look this slide, this is the vertex experiment and ML metadata, experiment parameters, dataset, and pipelines metadata. What is this feature? This is the system for tracking and managing the details of all your ML experiment. The storage location, obtain a database or serve like the Vertex ML metadata. Keep a record of everything that happened during each run. Experiment, a collection of model training run, each with its own set of parameter and result. You need to notice each of these key points actually, why you should use this, what purpose, what the advantage. You need to keep a point so that you can give the answer properly actually. Why you should use the experiment? Experiment is the collection of model training run each with its own set of the parameter and result. This allow for easy comparison between the different approaches and parameters, the hyperparameters and organization configuration setting used to train a specific model, learning rate, number of epochs, and metrics, the performance result of the model, such as the accuracy, precision, or recall. This is the crucial for evaluating and comparing the model. And when you use the dataset as a reference, instead of storing the entire dataset, you don't need to enter the entire data set within the metadata. This is the component hold the reference or pointer to dataset used for a specific experiment. This ensures the traceability without duplicating very large amount of the data. That is, you need to use just crucial information, crucial data set that you need to traceable and auditable to am- experiment or until from your large amount of data. And Bartex AI storage location. Bartex AI is a cloud managed platform for MLOps. It provides the tools and service for every stage of the ML life cycle, such as the train model. After model has been trained, it thrive the registered with the Vertex AI. This make it available for development and serving. This is an artifact of the training process. After that, artifact registry is one of the components of the Vertex AI, is a centralized repository for storing and managing the software package and image such as a Docker container. This the Docker container have three contain components feature such as a pipeline container. The code for each step the ML pipeline is often packaged into a container. It's called the Docker image to ensure consistency and portability across the different environment. These containers are stored here. This is an artifact of the pipeline build the process. This is basically the process that you already understand the why you should use the pipeline container, what purpose. Custom training environment. These are the pre-configured container images with all the necessary libraries and dependency like TensorFlow, PyTorch required for the model training. This ensure a consistent training environment. This is an artifact. This is an artifact. Custom prediction environment. We first I gave you the first key point, the pipeline container. Then I talk about the custom training environment. Now, custom prediction environment. When you use what purpose you use the custom prediction environment? These are the container image specifically designed for serving a model. They contain the model itself and code needed to make the prediction. This is an artifact. So you need to keep remember the details I mentioned here. Actually, when you work the artifact organization, what the best practice you need to follow. You need to follow the pipeline container purpose. You need to follow the container training environment as well as the custom prediction environment. Why and what purpose at which point you should use the custom prediction environment. It is Bartik's prediction. Bartik's prediction is the service with a Bartik's AI that handles the development and serving of the machine learning model. Such as deploy the model. These are the models that have been made available for use in the production application via the REST API or serving the endpoint. This is the final artifact of MLOps pipeline, representing and culmination of all the previous steps. So you already know what is the artifact and what the feature have the artifact and what's the point you should use this artifact. Now, based on this discussion, I will go through one the sample question. I will go through one sample question here. Uh, Sorry, before the sample question, I will discuss about the success of Bartik's model registry is something that give you the more understanding your concept. Suppose the Bartik's AI model registry manages and governs the life cycle of your model in the central repository that I discussed before. The register organize, track the version. You train and deploy the ML model. This is the overview. You need to think why you should use the model registry, why you should use the artifact registry, what the feature you have on this artifact registry, and what the advantage you have take. But there is a single. We are talking about the custom model trainings. Custom model trainings. It is the very sorry serial of working set of the work. You need to manage the pipelines, you need to manage the version, you need the model, the production development model and preprocessor model, different type of data set, and how you need to collect the metadata, how you can compare the metadata with each, how you can compare each version to another version. Everything we need to uh, uh, go through with this artifact registry organization and the model registry. Store the model metadata, the number of dependency for deployment state, maintain the model documentation, runtime dependency and development team, maintain the integrate with the model evaluation and development that I talked to you before, capabilities and tracks the online evaluation metrics for the model, govern the models, launch processes, review, approve, release, and rollback. This is the decision are based on the number of the offline performance and fairness, the metrics and online experiment result that I explained to you. Suppose you have a 536 tasks at a time. Now, not a this is the task, but you need to compare these tasks actually, which tasks go through in the right way and which tasks based on your expect prediction give you the proper accurate response. The for that reason, if you can't able to give and see and overlook the summarize of the report, what happening, where is what is happening, where is this problem, okay, and which data you are comparing with each other, which version to version, which model to model, everything you can compare here. So let us go through the next slide. Go through the next slide. The vertex A experiment that I talked, you need to do the experiment, comparison, the version to version, model to model, data set to data set, which data set give you the which type of accurate result, which version give you the which type of result you need to compare. You need to see the visualize to overview so that you can make the decision. Simple method, log the artifacts such as the dataset, model, and matrix, connected image graph. Easily query and consume the metadata, pulling back the run and data frame for the analysis. Leverage the flexible and extensible type of system to create the custom artifact types of and properties. This is why you should use the Bartik's AI experiment that I mentioned here. You need to see, evaluate your model actually how it will model work. Your model will not training just only for the one version. It should be the multiple version, multiple data set, or the different type of the variation, different type of the activity setting that you can compare. Bartex AI experiment main benefit. What the benefit you can get it using the track all run and metrics in the central places, a central dashboard for training and evaluation the run across the framework and environment. Visualize the compare multiple experiment that I talked already. Analyze the different training run with rich built-in visualization. Quickly compare the experiment and select the best model. Share the experiment and collaborate effectively. Source and discover the experiment across the organization with easy and share the finding easily. So you already know actually why you should do the Bartex experiment and what's the main benefit, and you already know the module registry and artifact organization, actually what purpose it was work, why you should work, what the benefit you are using, you need to keep remember when you say to the exam. The artifacts Linus described all the factors that result in the artifact. You need to keep what is the artifact Linus. Artifact lineage describe all the factors that resulted in the artifact. You can understand the difference in the performance or accuracy over the several pipeline runs. Artifact lineage, it's mean you running the multiple pipeline. The what pipeline? Each of the pipeline had a different type of the models and data set you have using to experiment to see actually what the accuracy of the result. So this is the artifacts lineage that you can compare the model pipeline performance and accuracy over the several pipeline you run, multiple pipeline you are running. You want to see that it is the pipeline picture output with this artificial readers. A model is readers could include the following: the training, test, and evaluation data used to create the model, the hyperparameter used to during the model training, the code that was used to train the model, metadata recorded from the training and evaluation the process, artifact that descend from this model. It is everything. When you run this pipeline and model and version, each of these running times, you generate a different of the metadata. You need to keep the crucial metadata information keyword that you need to compare with each other so that you can get the accurate result of your model training. Organize your ML model artifact and Git repo. Use the Git repo for pipeline and definition the training the code. Training the code. ML metadata, artifact readiness at execution for your ML workflow automatically track input and output to all the components in ML pipeline and their readiness. Visualize the workflow for faster debugging with DAG of all related execution. Manage artifact by the project group, by the experiment, and track the uses of the dataset and model in your organization. The full of these pipelines and its performance, what you have input, what you have out, get the output, you can see the visualized way, and you can comparize your each of the pipelines performance and their activities, and based on which type of metadata they are generating, and it was meet your custom trainings expectation so that you can compare both of result that you are expecting. Let us go through it now, one of the sample question so that you can understand my earlier discussion. Suppose you are training a model in a Bartex AI by using data. You are training a model in a Bartex AI by using a data that is spent across the multiple Google Cloud project. You need to find the track and compare the performance of the different version of your model. which Google Cloud service should you include in your ML workflow? They ask the question, you have the multiple project to training the model in a Vertex AI. Okay, you need to find out track and compare the performance of different type of the version of your model. The which Google Cloud service you should include in your ML workflow. Dataplex, Vertex AI Feature Store, and Vertex AI TensorBoard. B, Vertex AI Pipeline, Vertex AI Feature Store, and Vertex AI Experiment. And C, Dataplex, Vertex AI Experiment, and Vertex AI ML metadata. And D, Vertex AI Pipeline, Vertex AI Experiment, and Vertex AI metadata. What should be the? Suppose we've seen this, it's very familiar the D because the Vertex AI pipeline, Vertex AI experiment, and Vertex AI metadata is the feature of the Vertex AI platforms and artifacts registry. Let us this, the Vertex AI pipeline. You need to orchestrate a complete ML workflow which include fetching the data from multiple projects, training the model, and deploying them the Vertex AI pipeline. It is a service that allow you to define a series of steps in a reproducible and scalable manner. It is the core service for automating your entire ML work process, including the step to find, track, and compare the model. This is the question you'll say. The Vertex AI pipeline, this is you get the very feature here. Vertex AI experiment, when you are training the different version of your model, you need to way to track and compare their performance using the Vertex AI experiment. It is the design for exactly this purpose. It allows you to group and compare the different run or trial of your model training jobs. You can log the metrics like accuracy, loss, and F1 score for each trial, making it easy to see which model version performed the best. This service directly addresses the compare the performance of the different version of your model and requirement. So what does the Vertex AI metadata? For an organization and a traceable ML workflow, you need to find and track the artifact and their relationship. This is where the Vertex AI metadata comes in. It is automatically logs the metadata about your ML workflow, such as the location of the data set used, the model artifact created and hyperparameter of each training the run. This allow you to trace a specific model back to the data that was used to train it and parameters that were set and fulfilling the find and track requirement. This is especially crucial when your data is spread across the multiple projects, as it is the provide the centralized record of everything. So we understand why the D is the correct, because D have the Vertex AI experiment, Vertex AI metadata, and Vertex AI pipeline that can help you to run the multiple pipeline through the multiple project in a Vertex AI platforms. Let us see the other things. Why? What is this thing? Such as the A and C Dataplex is a data fabric service used to manage and govern the data across an organization. While it is great for data discovery and quality, it does not directly address the tracking and comparison of model performance of the orchestration ML workflow in the same way Vertex AI dedicated service do. A and B, Vertex AI Feature Store. Vertex AI Feature Store is used to share and manage the ML feature, which is useful in complete ML lifecycle. It is not the primary service for tracking and comparing the model performance. You could use it to manage the feature, but it does not solve the core problem of tracking model version and their metrics. I hope you understand. You you not only solve this sample question, you also understand the what is the data flex and what purpose you can use the data flex and what the Vertex A feature is stored and what the purpose you should use the data feature is stored. While in this question, they asked about the model tracking and compare, then Dataplex and Feature Store will not give you the model comparison and performance tracking facilities. For that reason, Vertex AI pipeline, Vertex metadata, Vertex experiment, it was the related. If you keep this keyword and simple overview yourself, it would be easy to understand you answer the question. While in the question talking about the model custom trainings, related is the debugging and performance comparison testing, auditing, version control, this etc. Let us go the next question. Next question was the regarded that you are developing a model to predict whether a failure will occur in the critical machine part. You have a data set consisting of multivariate time series and labels indicating whether the machine part failed. You recently started experimenting with a few different pre-processing and modeling approaches in the Vertex AI workbench in the notebook. You want to log the data and track the artifact from each run. How should you set up your experiment? You already know about the experiment. What does the experiment? But this is the question: how you should set up this experiment in the Vertex AI and workbench platform in the notebooks. Let us check out the four option here. Use the Vertex AI SDK. Just carefully point out these things. Use the Vertex AI SDK to create an experiment and set up the Vertex ML metadata. It is hard to take the concentration to find out the relation each with other because it is the question option is the to learn the option. But you need to follow the keyword, question talking about the setup. What the setup? The failure will occur the critical machine part. Approach in a Vertex works for experimenting the few different pre-processing and modeling approach. The latest data use the Vertex AI SDK to create an experiment, set up the Vertex AI ML metadata, use the long time series matrix function to track the pre-processed data, and use the log matrix function to log losses value. There is another key point. You should give some concentration about the function that contain the Vertex platforms and different type of features and function related to the debugging performance, such as the what is the purpose use the long time series matrix, what purpose use the log loss value. You need to overview to understand these things. Let us start option C, the create a Vertex AI TensorBoard instance and use the Vertex AI SDK to create an experiment and associate the TensorBoard instance. Use the assign input artifact method to track the preprocessed data and use the log time series matrix function to log loss value. Option D, create a Vertex AI TensorBoard instance and use the Vertex AI SDK to create an experiment and associate with the TensorBoard instance. Use the log time series matrix function to track and preprocess the data and use the log matrix function to log logs value. That's mean there is a while question indicating the experiment with the few different preprocesses and modeling approach in a Vertex AI workbench notebook. Now we need to give concentration. Actually, who is this one? Suppose let us see the number C, the create a Vertex AI TensorBoard instance with use the Vertex AI, associate it with the experiment. The Vertex AI TensorBoard is specifically designed for visualizing and tracking the experiment matrix, including the time series data. Associating it with your experiment allow you to view your tracking metrics. You need to keep remember the Vertex AI TensorBoard instance was the visualized with the experiment. So it associate it with your experiment allow you to view your training metrics such as loss value over a time in the graphical interface and use the assign input artifact to track the preprocessed data. What is the function I am talking? The artifact input assign input artifact to track the preprocessed data. The The method is used to an artifact with the case is your preprocessed data. This is the crucial for tracking the data lineage and ensure the reproducibility. I talked before that what is the vertex, artifact lineage. Artifact lineage give you the pipelines, performance and version context issue. You can so that compare each with other. So use the log time series matrix to log loss value. Since you are the training the model over a time epochs, the loss value and the time series matrix, the log time series matrix functioning is the appropriate tool for logging this value, which can be visualized in the vertex AI tensor board. That's been the tensor board is the main place you can get the benefit to experiment for different type of the export. So you need to configure the TensorFlow with the associate with the experiment. Let us see the other option. A and B are incorrect because they are recommending using the log time series matrix to track the preprocessed data. This function is for logging the matrix accuracy the loss over the time, not for logging data artifact. You should keep this point is together. Log can series the matrix to track the preprocessed data. This function is not logging the matrix for accuracy the loss over the time, not for logging the data artifact. Option D is incorrect because it is suggesting using the log time series matrix for preprocessed the data and log matrix for loss value. The loss value should be logged using the log time series matrix as they are time-based and preprocessed data should be logged as an artifact, not a matrix. So option C is the correct. Option C is the correct. So let us deep dive in the another sample question. Suppose you are developing a process for training and running your custom model in the production. You need to be able to show the lineage for your model and prediction. This is again for the model, the lineage, artifact lineage, model and prediction. What should you do? Create a Vertex AI managed data set, use a Vertex AI training pipeline to train the model, generate the base prediction in a Vertex AI. Option B, use a Vertex AI pipeline, the custom training job components to train your model. Generate a prediction by using a Vertex AI pipeline model based prediction. You need to keep the point when you read these things. Actually, what is the Vertex AI training pipeline? What is the base prediction? You need to keep this over view in your key point. Generate the prediction by using the Vertex AI pipeline model and base prediction component. Upload your dataset to BigQuery, use a Vertex AI custom training job to train the model, generate a prediction by using the Vertex AI SDK custom prediction routines, or option D, use a Vertex AI experiment to train your model. Register your model in a Vertex AI model registry, generate a base prediction in the Vertex AI. This is all about the lineage tracking in a Vertex AI. This is all about the lineage tracking in a Vertex AI. Keep this point. To show the lineage for the model and its prediction, you need the Vertex AI pipelines handle the execution of the lineage automatically. Pipeline component tracking and prediction record the input and output as an artifact in the Vertex AI ML metadata. This give you the traceability from the dataset, training, model, and prediction. So what the deep drive these things? Use a managed dataset plus training the pipeline plus the base prediction. Training the pipeline helps with the lineage, but just training the pipeline is too not it's not correct. The unless explicitly read to the Vertex AI pipeline, lineage approach the cross the prediction may not fully be captured. So if you create the custom training job inside the Vertex AI pipeline and base prediction component inside the Vertex pipeline, this ensure you end-to-end lineage, it trackable and track the ML metadata. So This is the best match for your requirement. So option B is quite similar for us. Let us the option C. Upload to BigQuery and custom training and custom prediction routine. No automatic lineage tracking across the training and prediction unless you may wear the metadata logging. And option D uses experiment plus model registry plus base prediction. Experiment good for comparing the model runs, but model registry good for versioning, but not sufficient for your full lineage because linking a data set, model and prediction and output. That means option B should be the best answer because the only vertex pipelines with the training plus prediction component ensure automatic end-to-end lineage tracking in a ML metadata. Do you understand this? If you, this is, I go through with a lot of crucial things here. If you give the some concentration, you can answer a lot of questions this kind of scenario. Because within the exam, you will familiar with the most of the question is try to focus of the vertex AI BigQuery, how you can use the best way and based in your use case. So if you keep remember this key point, it will be very helpful to understand your question and give you the answer easily. Let us the next sample question. You want to migrate a skittle classifier model to TensorFlow. You plan to train the TensorFlow classifier model using the same training set that was used to train skittle model. Then compare the performance using the common test set. You want to use the Vertex Python SDK to manually log the evaluation metrics of its model and compare them based on the F1 score and confusion metrics. How should you log the metrics? Let us see the option. Use the API platform log classification matrix function to call the F1 score and use the API platform log matrix function to log confusion matrix. So what you need to do? Actually, you need to give the concentration about this function. What is the function have I said before in the Vertex AI platform for different type of model experiment, different type of metadata experiment, this kind of, if you know each of them, the overview, then you can remember, oh, this one this purpose, this one this purpose, you can compare and which one is the best for your use case, then you can choose this, then it will not feel the boring and you will not feel the hard and complex here. Option, let us see the option B. Use the AI platform dot log classification matrix function to log F1 score and confusion matrix. Use the API log matrix function to log F1 score and confusion matrix. Option D, use the API platform log matrix function to log F1 score and use the AI platform dot log classification matrix function to log the confusion matrix. You just keep the note yourself, okay? Because it very hard to concentration yourself. I'm talking which one with which one to which one. Go through it slowly, okay? And compare with these things. Actually, I compare which one to which one, combination, which one to which one. Okay, let us see the AI platform log metrics. The log scalar metrics like loss accuracy, F1 score, you can define this. AI platform dot log classification metric is specifically for classification problem. Log aggregated classification matrix, precision called precision and recall, F1 and log, and artifacts like confusion matrix. This is the right API when you want to log both F1 score and confusion model. So I define the key function for you, the log aggregated classification and classification problem used. This is the AI platform that log classification module API give you the both F1 score and uh, confusion matrix to call. The log F1 with log classification matrix is the correct, but log confusion matrix with the log confusion matrix with log matrix is the wrong. Confusion matrix are not scalar. Must go to the log classification matrix. You should learn about the details actually. What is the confusion matrix? When you should use the confusion matrix? Which type of use case and problem can support the you can get so the confusion matrix and with the log matrix, and F1 is equal to log classification matrix. Which type of result you can get it, you can check this note from the Google Cloud documentation. That will be easier for you. The latest, the option B, the logs F1 plus confusion matrix, both with log classification matrix is the correct. But exactly how Bartex AI SDK is designed for the classification tags, we are totally talking about the classification tags in the question. So log F1 plus confusion matrix, both with the log classification matrix is the correct. Exactly how Bartex AI SDK is designed for the classification tags. But option C, log both with the log matrix, wrong. Confusion matrix is not supported here. The the which confusion matrix is not supported here. The D, the log F1 with log matrix should use the classification matrix since this is the classifier. This it is not the correct. Log confusion matrix with log classification matrix, including confusion matrix, be the passed alongside the matrix, not alone. So correct answer should be the B because the API plat, API plat, AI platform log classification matrix is the right function for logging both F1 score and confusion matrix is a classification cortex. The how you digging up after deep dive on this question, you need to know actually check your documentation like this way. Actually, which function and method will go through which function is common. Sometimes give you you use the A and B. Okay, A and B. How if you compare, what will we give the result? Actually, A is support with the B or B is support with the A. You can compare like this, then you will be easier to understand the documentation to fair. You can read it really, a lot of people can catch it, but some of the people will not catch it actually. What the point, how we will give the consideration for exam while you read the Google Cloud documentation about the model trainings, function and feature. You need to think like this way. Okay, let us go the next sample question about you work on a team that build state-of-art deep learning model by using the TensorFlow framework. Your team run multiple ML experiments each week, which make it difficult to track the experiment run. Key concentration here. You want a simple approach to effectively track, visualize, debug the ML experiment run on Google Cloud while minimize any overhead code. How should you proceed? Option A, set up Vertex AI experiment to track metrics and parameter. Configure a Vertex AI TensorBoard for visualization. Set up a cloud function to write and save the matrix file to cloud storage bucket. Configure a Google Cloud VM to host TensorBoard locally for visualization. Option C, set up a Vertex AI Workbench notebook instance. Use instance to save the matrix data in a cloud storage bucket and host TensorBoard locally for visualization. Set up a cloud function to write and save the matrix file in a BigQuery table. Configure a Google Cloud VM to host TensorBoard locally for visualization. Let us check the key point actually. Uh, what the feature we are each option calling they have. Suppose the TensorFlow based the deep learning and multiple experiment per week need the visualization and debugging. Consider the question. TensorFlow based deep learning you need to. This is the multiple experiment per week. Need experiment and tracking. Also need visualization and debugging. The metrics, curve, loss, and accuracy. Minimizing overhead the code must be simple not to manually the logging. In the option A, Vertex A experiment plus Vertex A TensorBoard experiment automatically track run and metrics and parameter. and TensorBoard managed by in a Vertex AI, purpose built for deep learning visualization. You got your key point. The deep learning visualization loss accuracy, curve, histogram, and embedding. Also, it was minimal overhead. Vertex AI SDK integrated directly within the TensorFlow. Cloud native, no need to manage inference. This is the best fit for your problem. And option B, cloud function plus VM hosted tensor board. Manually setup of writing the matrix and deploying the VM for the tensor board. Add the overhead and maintenance the burden. But the question says the minimal overhead. So this is not the match with this solution. Workbench and Google Cloud and local TensorBoard still require hosting the TensorBoard manually. Add extra manually step, not minimal of it. I hope you give the constraint that you need to digging up actually t- about the TensorBoard actually when it was the best, when it is not the best. Okay, how you need to set up, where you need to set up, if you need to set up in the locally, and what the benefit you will get, and how you will be communicate with the others components, and what it is supporting and what is not supporting. You need to keep point here. And option D, cloud function and BigQuery hosted, VM hosted in a TensorFlow. Even the more overhead, because BigQuery is the different platform, is not the right tool for experiment the metrics. So VM managed add unnecessary complexity. Where Vertex AI have their own experimental um, interface for tracking, visualizing the multiple pipelines and everything. So you don't need to go through the BigQuery because it will give you the more overhead and very difficulties. So this is the option A is the correct because the Vertex A experiment plus TensorBoard provide the simplest managed low overhead solution for tracking, visualizing, and debugging the TensorFlow experiment. You got your answer. You should keep remember the Vertex AI experiment plus TensorBoard provide the simplest managed over low overhead solution for tracking, visualizing, and debugging TensorFlow experiment on the Google Cloud. While you talking about the custom model training, you must be giving the deep concentration how you will monitor this custom model training statics, how you will compare these statics with each other. What the best solution in a Google Cloud you can use? Not only the best platform or best feature, you need also give the concentration. What's the function give you the right decision? The latest another sample question to the drives. Suppose you have created a Vertex AI pipeline that automated custom model training. Custom model training, you want to add a pipeline, the component the metrics both visualize and programmatically. What should you do? Add a component to a Vertex AI pipeline that logs the metrics to the BigQuery table. Query the table to compare the different execution of the pipeline. Connect the BigQuery to Local Studio to visualize the metrics. Second one, B, add a component to the Vertex AI pipeline that logs the metrics to the BigQuery table. Load the table into the Panda data frame to compare the different execution of the pipeline. Use MetaLab to visualize the metrics. Option C, add a component to the Vertex AI pipeline that logs the metrics to Vertex available metadata. Use Vertex AI experiment to compare the different execution of the pipeline. Use a Vertex AI TensorBoard to visualize the metrics. Option D, add a component to the Vertex AI pipeline that logs the metrics to Vertex AI metadata. Load the metrics and ML metadata into a Panda data frames to compare the different execution of the pipeline. Use Metapilot leaf to visualize the metrics. Let us look carefully at each of the point. You already have a Vertex AI pipeline into the Vertex AI platform, and you want to component that allow the team to easily collaborate to each other. Then comparing the execution programmatically, suppose Python and SDK, and compare the execution visually with built-in visualization. The option A, log matrix to BigQuery plus Looker Studio, possibly but not the native ML pipelines. It is totally different platforms for data visualization. Require extra setup, BigQuery, schema, and Looker dashboard. More work for data engineer, not simplest for the ML team. Let us see the again to the option B, the log matrix to BigQuery, pandas plus meta, meta visualization and comparison are local, not collaborator across the team. You have no this collaborator option there, and again it is should be you should set up the manually. The option C, log matrix to vertex MLI metadata plus use vertex A experiment plus cancer board. Vertex MLI metadata we know automatically capture the lineage dataset model vertex metrics from the pipelines, and vertex A experiment let us track and compare the run programmatically and visually in the vertex AI console. The vertex AI tensor board integrated directly for the visualizing the training curves and metrics. The cloud native and collaborative and minimal overhead. That means C is the best matches with this scenario. The log matrix to ML metadata plus Panda and metapolit lives programmatically compressing the possible but not good for collaborative and visualization. Again to manual. So the option C should be the best choice because we got the vertex able metadata, vertex AI experiment, vertex AI tensor board, and we know what purpose we can use this option. The option C is the correct, and because it used the purpose built-in vertex AI stack, metadata plus experiment plus tensor board for exactly this use case, the team collaboration, run comparison, and programmatic and visualized trackings. You need to find out the question objective. Okay, you need to find out the question exactly actually what they actually want to reveal. Okay, then give the keyword actually which platform are very similar and easiest use you can use, then you can find it out your required answer. Let us another sample question see. You are investigating the root cause of the misclassification misclassification error made by one of your model, and you use to vertex a pipeline to train deploy the model. The pipeline reads the data from BigQuery, create a copy of the data in a cloud storage in a TF record format, train the model in the vertex AI training on that copy, and deploy the model to the vertex AI endpoint. Sorry, and you have identified the specific version of the model that misclassified, and you need to recover the data this model was trained on. How should you find that copy of this data? You take this key point. Option A, use the vertex AI feature store, modify the pipeline to use the feature store and to ensure that all training data is stored in it and search the feature store for data used for the training. Option B, use the lineage feature of the vertex AI metadata to find a model artifact, determine the version of the model that identify the step that create a data copy and search the metadata for its location. Option C, use the logging feature in the vertex AI endpoint to determine the timestamp of the model's development. Find the pipeline run that the timestamp, identify the step that create the data copy, and search in the logs for its location. Option D, find the job ID in the vertex AI training corresponding to the training for the model, search the logs of the job for the data used for the trainings. Looks carefully. Problem is model was trained and deployed via the vertex AI pipeline. And data flow, BigQuery copy the tensor record, vertex AI training, and deploy the model. You know which model version misclassified. You need to recover the exactly training data copy. This is the about the lineage tracking. trying to model the artifact back to the specific data set copy used to training. This is the exactly what the vertex metadata lineage for used for. So you know the use the features store. This is the pipeline does not use the feature store and would require the rebuild the pipeline to use it. Not relevant here. The option B use the vertex AI metadata lineage. Metadata automatically logs the artifact and lineage from the pipeline run. You can you can track from the model artifact back to the training step, back to the data copy artifact in the GCS. This is the intent and most reliable way. You find out this is the which one the most relevant way, and use the endpoint and logs and timestamp. You might be find the development time that, but that does not guarantee to trace a specific training data copy. Log don't maintain the exactly data set and the lineage. Option D, use the job ID plus training logs. Logs might mention the data path, but this is a manual unreliable. No structural lineage, just hawk the logic scrapping. So option B would be the best choice for us because the vertex metadata lineage give you the structure way to trace the artifact model and dataset copy in the Google Cloud storage without guesswork or manual log searching. Let us deep dive the another sample question. You create an ML pipeline with multiple input parameter and you want to investigate the trade-off between the different parameter combination. The parameter option are input dataset. Give the consideration the key point. Input data set, max tree depth of boosted tree regressor, and optimize the learning rate. You need to compare the pipeline performance of the different parameter combination measured in a F1 score, train to train, time to train, and model complexity. You want your approach to be the reproducible and track all pipeline run on same platform. What should you do? Let us find out the option. Use the BigQuery ML to create a boosted tree regression and hyperparameter tuning capabilities. Configure the hyperparameter syntax to select the different input, dataset, max tree depth, and optimize learning rate. Choose the grid search option. Option B, create a vertex AI pipeline with custom model training job as a part of the pipeline. Configure the pipeline parameters to include those you are the investigating. In the custom training step, use the Bayesian optimized method with F1 score as the target to the maximization. Option C, create a vertex AI workbench notebook for each of the different input data set. In each notebook, run the different local training jobs with a different combination of the max tree depth and optimize the learning rate. After each of the notebook and finishes, append the result of the BigQuery table. Option D, create an experiment with the vertex AI experiment and create a vertex AI pipeline with the custom model training as a part of the pipeline. Configure the pipeline parameters, including those you are the investigating. Those suppose in the question you can look the you have a pipeline with multiple input parameter, data set, max depth, and learning rate. You want to study the trade-off between them and multiple run. You need it to be the reproducible, and you want to all run to be the track on the same platform for comparison. You care about the F1 score, training time, and model complexity. The option A, BigQuery ML with the hyperparameter tuning. Big, BigQML does not support the hyperparameter tuning, but it does not let you. BigQuery does support the hyperparameter, but it does not let you to switch input dataset in the same syntax easily. You got the one point. Also, you specifically already have the pipeline, not just a SQL model. Limited flexibility, but custom ML pipeline setup. It was not totally matched with our requirement. Latest option B, vertex AI pipeline plus Bayesian optimization. Partially, it should be correct because you can configure the pipeline parameter params and optimize for the F1. But Bayesian optimization optimized for a single objective matrix F1 here. But does not allow to explain the trade-off across the multiple metrics, F1 training time and model complexity. Option C, multiple workbench notebook plus appended to the BigQuery, the very manual, hard to reproduce and scatter in the notebooks, as well as not the same platform tracking, not the centralization. The option D, Vertex AI experiment plus pipeline with the parameterized run. You can configure the pipeline parameter, dataset max in depth and running rate. Submit the multiple run with a different prompts combos as well as track all run under the same Vertex AI experiment. You can compare the metrics F1 and training and complexity both programmatically and visually, centralized and reproducibility and and collaborative way. The, it was the great mess, the D, the Vertex AI experiment pipeline with parameterized run. Because the Vertex AI parameter plus pipeline give you the reproducibility pipeline, comparison across the multiple run experiment, tracking visualization on the same platform, as well as give you the ability to study the trade stuff across the matrix, not just optimize one. The latest, the another sample of question, you are developing an ML model in a Vertex AI Workbench notebook. You want to track the artifact and compare the model during the experimentation using the different approach. You need to rapidly and easily transition successfully experiment to production as you iterate on your model implementation. What should you do? Option A, initialize the Vertex SDK with the same of your experiment, log parameter, matrix per experiment, and attach the data set and model artifact as an input and output to each execution. After the successful experiment, create a Vertex AI pipeline. Option B, initialize the Vertex SDK. Initialize the Vertex SDK with the name of your experiment, log parameters and metrics for each experiment. Save your data set to the cloud storage bucket and upload the model to the Vertex AI model registry. After a successful experiment, create a Vertex AI pipeline. Option C, create a Vertex AI pipeline with the parameter you want to track and argument to your pipeline job. Use the matrix model and dataset artifact types from the Qflow pipeline DSL and as the input and output of the components on your pipeline. In your pipeline, associate the pipeline with your experiment when you submit the job. Option D, create a Vertex AI pipeline, use the dataset and the model artifact types in the Qflow pipeline as the input and output of the component in your pipeline. In your tracking component, use the Vertex AI SDK to create an experiment run configuration logs params and log metrics function to track the parameter and metrics of your experimenter. Let us go through this. Suppose you are in the question, we see the keyword, we need the experiment in a Vertex AI workbench. So ad hoc run for iteration, first iteration. Also, we want to track the artifact matrix parameter during the experimentation, as well as compare the model across the process and rapidly transition successfully experiment into the production. So pipeline ready. So the correct answer need to be use the Vertex AI experiment for tracking the run and capture the artifact data state and model in the metadata. Provide a smooth path notebook experimentation plus Vertex AI pipeline for production. The option A, use a Vertex SDK to log param matrix dataset model as an input and output. After a successful experiment, create a Vertex AI pipeline. Flow is exactly how Google recommend the notebook experimentation with the Vertex AI experiment plus metadata then productionized via the pipeline. This is the strong candidate. Okay. Other option, the log params, suppose the option B, log params and matrix, but save the data manually to the Google Cloud storage and upload the model in the registry. This loses the automatic lineage artifact, tracking the advantage of the Bartex AI experiment. Metadata were more manual and overhead compared to the A. The option C is suggesting the starting directly with a pipeline using the Kubeflow DSL artifact. But the question context is the notebook experimentation first, then transition. The two heavily override wait for the early iteration. The option D, build a pipeline first, then logs experiment metrics inside the training components. Again, the not aligned with the start in the workbench notebook, then move the production. The strong tendency is the question A, because it uses Bartex AI experiment plus metadata to log the matrix param dataset and model during the notebook experiment and make it the result the comparable and reproducible. Also, it provides a clean transition to the Bartex AI pipeline once a good approach is found and meeting the rapid transition to production and requirement. Then question A is the correct. Now, since the every single point, if you go through with it against, you will find that which is the best solution for you. We several sample question I discuss here. Everything is focused actually how when you custom training in a Batkse platform, which feature give you the more comparison, flexibility to debugging and experimenting, you already know these things. So if you go through it, is again you will get the more clarification. Let us another sample question. Uh, okay, we will go through the next slide about the okay, we can give the another example. Let us say the your team is training a large number of each of every sample question is so important. You know, when you give the in a real exam, you will familiarize this sample of this question and what's the problem I am discussing. Okay, you will find out there. Okay, if you give some concentration, the comparison that you would be easy for you to get the right answer. Suppose your team is training the large amount ML model that use the different algorithm parameters and data set. Some models are trained in the Vertex AI pipeline and some are trained on the Vertex AI workbench notebook instance. Your team want to compare the performance of the model across the both services. You want to minimize the effort required to store the parameter and metrics. What should you do? The option A, implement the additional step for all the model running in a pipeline and a notebook to export the parameters and metrics to the BigQuery. Option B, create a Vertex AI experiment, submit all pipeline as an experiment run for model trained on the notebook, log parameters and metrics by using the Vertex AI SDK. Impl- Find out actually which option belongs to which platforms. Implement the all models in the Vertex AI pipeline, create a Vertex AI experiment, associate all pipeline runs that experiment. Store all model parameter and metrics as a model metadata, Vertex metadata API. Let us carefully evaluate it. The model trained in both a Vertex AI pipeline and Vertex AI Workbench notebook need to compare the performance across the both services. And also, we want to minimize the effort in storing the parameters plus metrics. So, what should be that? Work across the both pipeline plus notebook, as well as provide a common place to log and compare, and requirement minimal extra work. In the option A, export a params and metrics to the BigQuery manual setup for both pipeline and notebook, and custom schema design and ETL and queries, not minimal effort. Option B, create a Vertex AI experiment. Pipeline must run an experiment. Notebook log params plus metrics via the Vertex AI SDK using the log params log metrics. Give you the good result. Give a single experiment view in a Vertex AI experiment and minimal overhead since the experiment integrate directly with both. So this is the same platforms give you the overall comparison for between two these platforms. This is the best match. And option C, implement all model in the pipeline. and require rewriting the notebook experiment into the pipeline, as well as high overhead, not aligned with the minimum effort. Option D is to the params and metrics with the Vertex AI metadata API, possibly but require the manual logging the code and raise constraint for the comparison if we compare it with the experiment UI in a Vertex AI platform, and more effort than option B. So correct answer should be the B, because the Vertex AI experiment provided a unified low effort solution to log, compare, run across the both pipeline and notebooks. Let us see the another sample question. You are training the model in a Vertex AI by using the data and span across the multiple Google Cloud project. And you will need to compare the model of different version of your model. Which Google Cloud service should you include your ML workflow? It already I answered this thing. The Vertex AI pipeline and Vertex AI pipelines and Vertex AI experiment and Vertex AI metadata should be the best choice. It is all because Databricks and Database is not in the same platforms. Here is another question, sample question. We can go through it. Suppose you have a custom jobs that run on the Vertex AI on a weekly basis. Look carefully on this use case. The job is implement using the proprietary ML workflow that produce the data state model and custom artifact and send them to the cloud storage bucket. Many different versions of the data set and model were created due to the prediction and need access to the artifact for each model. How should you configure your workflows to meet this requirement? There is option A, use the Vertex AI metadata API inside the custom job to create a context of execution and artifact for each model and use the event to link them together. B, create a Vertex AI experiment and enable the auto logging inside the custom jobs. Option C, configure a TensorFlow extended ML metadata set and use the ML metadata API. Option D, register each model in the Vertex AI model registry and use the model label to store the related dataset and model information. So I feel like the correct answer should be the A, use the Vertex AI metadata API inside the custom job to create a context, execution, and artifact for the each model and use the event to link them together. Because of the track which model was used to the particular prediction, require the lineage tracking, and Bartik metadata give you the best option for the lineage tracking. Access the artifacts, dataset, model, and custom output for each model need to capture all artifacts generated per run. Multiple version of the dataset and model link them to the execution. So this is the option. A option is the correct. But Bartek's A experiment plus autologging experiment that tracks the matrix and parameter but do not automatically capture the artifact and full lineage for compliance the purpose. So option B is not correct. So TFX model and metadata plus API only apply if you are using the TFX pipeline your workflow to the custom. So TFX is not the required here. And model registry plus variables. Model registry tracks the model version but is storing the artifact lineage via the label in a manually. Error prone that not sufficient to compliance the tracking. So, but using the Vertex AI metadata API provide the full artifact and lineage tracking required for the compliance. So option A was the correct. If we see the another sample question, you work for a bank, you have been asked to develop an ML model that will support a loan application for the decision. You need to determine which Vertex AI service to include in the workflow. You want to track the model training parameter and metrics per training epoch. You plan to compare the performance of each version of the model to determine the best model based on your chosen metrics. Which Vertex AI service should you use? You already know this thing because several sample question I have answered I hope you guess which one is the correct already. So I will not go through this thing. Now I go to the next slide about the workbench. About the workbench. Workbench, Batik say workbench. Batik A Workbench is a notebook deployed in a single development environment, and Batik A collabs. Batik A collabs. So this is another platform that you can implement your model training using the BigQuery and other platform integrating and run your code in a visually to create in the instant and combination to, others platform like the BigQuery. The latest degree of the how it you can implement it into the through the Workbench and the BigQuery. If you check this the slide, here is the code syntax how you can calling the BigQuery inside the Workbench instance. Workbench instance. This is just a lab practice. So when you go through the Google Quality Skill Boost, I will provide the links here about how you can implement the Workbench is a practically step by step. I will give you the some reference link that you can go through with it. I will also discuss here about the work-based capabilities and advantages and how you can debug and monitor the performance in comparison with the other option in with the vertical platforms. Let us the next slide and check out these sample questions actually, then you will understand actually. You are developing a recommendation engine for an online clothing store. The historical customer transaction data is stored in a BigQuery and cloud storage. You need to perform exploratory data analysis and pre-processing and model training. You plan to return the EDA and pre-processing and training the step approach of the running this step as you experiment. How should you configure the environment? How should you configure that? Option A, create a Vortex A Workbench user managed notebook using the default VM instance. Again, I skip there is the some of the theoretical about the Bartics. When you read about the Bartics Y evidence, you need to give the consideration which use case is the best solution to use the Bartics A workbench and what kind of advantage you can get and what kind of experiment you can do over there. Okay. Option B, create a Vertex A Workbench managed notebook to browse and query the tables directly from the Jupyter Web interface. Option C, create a Vertex A Workbench user managed notebook on a Dataproc Hub and use the BigQuery magic command in the Jupyter to query the tables. Create a Vertex A Workbench managed notebook on the Dataproc and Cluster and use the Spark BigQuery connector to access. So if we can go through it with actually, this is the suppose the option A and C, user manage the notebook, give you the more control, but also require a more manual effort to set up and manage. You are responsible for the VM instance and its maintenance, which increase the development effort. While you can still use the BigQuery Magic command, it read the seamlessly built-in browser that manages the notebook provide and you miss out and cost-saving feature like automatic ideal shutdown. At option C and D, Dataproc Hub and Dataproc Cluster, while Dataproc is an excellent choice for large-scale data processing with Spark, it is an unnecessary and more complex layer for EDA at model training described in this scenario. Using a data flow cluster require more setup can be more costly for interactive exploratory work and training the small to a medium size of this model. This native integration of managed notebook are sufficient and most cost effective for this task. So if now you go through with this option B, Create a Bartex AI workbench managed in the notebook group to browse and query the tables directly from the Jupyter Web interface. This is the approach provide the best balance of the cost effective, easy of use, and integrate of your specific need. Manage the notebooks are fully managed service, meaning the Google Cloud handle and undertaking your infrastructure, security and update. This significantly reduces your development effort compared to the user managed notebooks where you are responsible for VM configuration and maintenance. Managed notebook also have a feature like an ideal shutdown which helps you to minimize the cost when you are not actively using the notebook. You already understand the managed notebook and user managed notebook difference. Direct BigQuery and cloud storage integration. Vertex AI workbench manage the notebook have built-in integration that allow you to browse and query the table in a BigQuery and files in the cloud storage directly from the Jupyter Live interface. And this is the same race and low effort way to access your data without needing to write a complex code of configuration additional connector. This is the directly address the need to minimize effort during the experimentation phase. You've seen my previous slide. I show you the snippet of the BigQuery calling code in the workbench instance. How easy just you just run the simple SQL query over there, and you can directly call the BigQuery data and visualize into the workbench instance. If you use the workbench managed instance, then you don't need to manage the infrastructure and others maintenance issues you that give you the overhead on you and costly. If you use the user managed, then will be the overcost to you, and it will take time to maintain the infrastructure, security, and others related with the infrastructure management. Let us another sample question. You are working on a prototype of the text classification model in the managed Vertex AI Workbench notebook. You want to quickly experiment with a tokenized text by using the natural language toolkit library. How should you add the library to your Jupyter kernel? Install the analytical library from the terminal using the pip install analytica command, or option B, write a custom data flow job that use the NTKL tokenize your text and save output to the cloud storage. Option C, create a Vertex AI Workbench notebook with the custom image included the analytical library, or install the NTKL library from the Jupyter cell using the pip install NTKL user command. Which one? It is very similar in the option D. Install the NTK library from the Jupyter cell using the pip install NLTK user command. Because you are experiment quickly in a managed Vertex AI Workbench notebook. This is the question said. You need to add a Python library to the notebook kernel. And goal is rapid prototyping, not the productionized pipeline yet. This is just for the experiment. And you need to install the Python library in the notebook kernel using the managed Vertex AI Workbench notebook. So using the pip install NTK user instance is a Jupyter cell and install NLTK directly into your notebook environment. No need to restart the notebook kernel in the most of the cases. And quick and simple prototype and experiment yourself. And users ensure the installation in the current user environment, avoiding the permission issue on the managed notebook. Other option, why the install from the pip install the NTK work with some setup, but managed notebook obtain restricted the terminal level installation. Using the user in a notebook cell simpler and avoid the permission issues. And option B, write a custom data flow job. Overall, kill the simple tokenization experimentation and unnecessary complexity. And create a new notebook with the custom images useful for the production ready environment, but for a quick experimenting created the custom image is the time consuming. So as the D is the first and simplest way to add the NLTK for prototyping and to manage Vertex AI work with notebook. You have noticed there is a question to focus on the one library installed on your VM. They define you need to use the managed instance. Okay, if you're managed inside the Python kernel, so which library where you should install, okay, what type of VM instance installs, if it was the user managed VM instance or if it was the Google Cloud managed instance, what the difference and flexibility. If they talk about the minimal effort, then you need to focus the managed Google Cloud managed instance that give you the minimum effort and faster way to install your library. And what kind of support uh, give you this sorry, this pattern library and permission issue on the instance level, because managed instance you should go through with your own permission configurations everything, but if you use the Google Cloud managed instance you will automatically get the specific library, get the automatically permission, so you don't need to be take the extra headache and complexity. Latest training environment. Talk about the training environment. Training environment is a crucial steps unit, because when you training the model, you need to a smooth environment that will run your custom model training, data pipelines, whatever you can say. What kind of things you need to be give the consideration? Let us give the some simple overview. You need to take a consider the factors: data requirement, accuracy, training time, hardware dependency, hyperparameter tunings. It is the common. Suppose you choose your environment. This is the environment or is appropriate for your model development and custom training. What kind of hardware and dependency you need to take consider? Well, is it the hyperparameter tuning capabilities? And you need to check the data, what kind of the data and accuracy you need to take consider. And deep learning require the large data and provide the high accuracy, take a longer to train, require the GPU to train the properly. Can you train the various different way? As well as using the machine learning, can the train the less data, give the lesser accuracy, take the less time to the train on the CPU, limited tuning capabilities. It's mean when you choose the your environment, you must be checked what kind of custom model you can training. Are you able to support the deep learning capabilities? Is it just the machine learning capabilities? And you need to give concentration some of the factors that the first stage you need to check your data requirement and accuracy and hardware dependency, hyperparameter tuning facilities. After that, you need to check the what kind of the GPU you need to train, and it can be the profiling. What kind of others platform you can combine with this. This kind of things you need to be to consider when you choose the environment. Otherwise, all of this environment, every environment will not suit your use case. Different use case and requirement will be the different environment. You need to set up different type of permits, different type of the hardware capacity, different type of the model running and evaluation and tracking facilities you need, and different type of function and API you need to call. You need to check so which platform are supporting which type of experimentation logic and platform. You need to find out these three steps you need to take consider. You need to check the factors, you need to check the deep learning capabilities, you need to check the machine learning's capabilities. Let us the Bartik training support for TPU port. This is the hardware solution for your Bartex training, where you are the custom model training in the Bartex AI. Bartex AI training support for TPU pod is the fully managed service for running job at a massive scale and spine up TPU pod on the demand and pay for what you use. And Bartex AI training retrain the logic simplify the execution of your long running job. And TPU and MLOps the training the job part while use the benefiting from the Vertex AI RISC-MLF's capabilities. That means you can use the TPU part in the Vertex AI platform while you will run the very massive and very large data model trainings. When you run the very large data set and very complex model training, you need to do the very high and complex computing resource so that you can run your model training, do the experimentation. So you need to support the hardware and computing capabilities. So this is the TPU is the very high scalable data set, complex machine learning model you can train it, and it was supported by the Vertex AI platform. Vertex training reduction in the server, optimized distributed GPU training for synchronize the data parallel algorithm. Training the time is the key. This is the experimental growth of dataset and model size that has captured the training time to become one of the key bottleneck in the development of the ML system. And distributing the training at scale is difficult. To speed up the training of the large model, many engineering teams adapting their distributed training using the scale out of the cluster and the ML accelerator. However, limited network bandwidth between the node makes you the optimized performance and distributed training inherent difficulties, particularly for the large cluster configuration. And reduce the server allow for faster distributed training. Reduction server and faster GPU all reduce the algorithm development, and Google is the new Vertex AI feature that optimize the bandwidth and latency of the multi-node distributed training, the NVIDIA GPUs for synchronous data parallel algorithm. And it was the framework agonistics support to the mainstream deep learning framework, including the TensorFlow, PyTorch, and JAX. Seamlessly integration with the existing training job. This is the zero-touch enablement for multi-worker GPU to training jobs to Vertex AI training with optimize the training bandwidth and the latency. That's not you find out your solution. When you work with the large scale model training, complex computing model trainings, and multiple uh, base trainings run in the at a time, what you need the scalability, you need the latency support, you need the cooperatives and the flexibility weight with over the network bandwidth that make the optimize the performance and distribute the training inherently and overcome the difficulties the cluster configuration. That means Google Vertex AI and TPU port, it was the Google managed service, and it will automatically manage for you all kind of this configuration that you need to run the complex um, and high scalability model training. As well as it was support to the different type of the tensor deep learning framework, including the TensorFlow, PyTorch, and other. So you should keep remember TPU's advantage and what kind of operational and management issue you can overcome while you are training the custom model training in the large scale environment, large scale within the computing resource. The let us go through it. If you here is you can see the one chat here. There is you can see the Vertex AI configuration GPU worker per hour. This is the experiment of how GPU worker and how long time to take and cost. This is the also you can check the cost optimization pace and price comparison pace. How you can reduce your cost while you are training the complex model in a Google Cloud Vertex custom model trainings. Here is this chart to show you there is two type of machine choose and how much you have spent for per hour, okay, and how much percentage you can cost per step by the 40 to even the additional nodes. This is totally your costings summary. This is just a simple comparison. Okay, this is just a simple comparison. When you choose the TPU, you need to choose the worker nodes. Okay, you need to choose the deep learning framework, deep learning framework. Then you find out. Sorry, then you choose the machine types, then you will get the appropriate idea actually how many node and worker and how long time it will take and how much will be cost. You will get the and one experimental of this comparison of the cost, that this is the percentage you can reduce. For that you can check the price calculation page. I will give you the reference link over there, and also I will give you the in details one of the reference link. Actually you can understand what is the best practice to using the TPU and how you can overcome the custom model training latency and distributed parallel processing and different type of machine type based on the framework, how you can save your and everything. I will provide the one reference links. There is a time is limited, so I will on these topics I will go to some of the sample questions so that you can understand what kind of the question in a real exam will focus based on the vertex custom trainings on the TPU pod, and what kind of initiative decision you should take, and what kind of best practice you need to follow while you are the custom trainings using the pod TPU pod. Let us these sample questions. You are training a custom language model for your company using the large data set, and you plan to use the reduction, the server strategy on the Vertex AI. You need to configure the workflows of the distributed training job. What should you do? Configure the machine of the first two worker pools at the GPU, and you say why I did not go through with the more TPU explanation, because I will give you the explanation through the sample question so that you can directly identify about the TPU uses best practice and custom model training best practice is the large and complex dataset model trainings. So let us follow this option. Option A, configure the machine of the first two worker pools to have the GPU and use the container image where you the training the code run, and configure the third worker pool to have the GPU and use the reduction server container images. Option B, configure the machine of the first two worker pool to have a GPU and use the container image where your training could run. Configure the third worker pool to use the reduction server container image without accelerator and choose the machine type that priorities the bandwidth. Look the key point. Configure the machine of the first two worker pool and have the TPU and use the container image where your training could run. You should check the worker pool and training code run environment. Okay, configure the third worker pool without the accelerator and use the reduction server container image without the accelerator, and choose a machine type that prioritizes the bandwidth. Here is the another key point. Configure the machine of the first two pool have TPU and use the container image where your training code run. Configure the third pool to have the TPU and use the reduction server and container the image. Let us find out the each of these option key point. First, I will go to the option B. Let us see the reduction server strategy on the Vertex AI is designed to improve the performance of distributed training by offloading gradient reduction from the main training worker to a dedicated set of the machine. This free up the accelerator like GPU on the training worker to focus the solely model trainings on, because the first two worker pool is the training workers. The first two worker pools obtain a chief and worker pool, and where you actually the model training happen. Need a powerful machine within the GPU to handle the computational intensive tasks of the training a large language model. You must use a container image that contain your training code as it is what will be executed on this machine. Third, third worker pool is the rejection server. The rejection worker pool is a dedicated group of machines that will run the rejection server, and this is the server is the primary job to handle the communication overhead of aggregating gradient from all of the training worker. Because this task is the input and output bound rather than the compute bound, this machine do not need the GPU. Instead, they should have a machine type that prioritizes the bandwidth to efficiently handle the large volume of data being passed between the worker. This is the achieved by specifying the reduction server container images. O- Um, Container images. So you understand why the option is the B option the correct, because first two worker is the training worker and third worker is the reduction worker. And reduction worker is the machine type that prioritizes the bandwidth, is the efficient handle the large volume of data and being passed between the worker. So option B is the correct, but let us see the option A and D. The A and D, this is the option is incorrect suggestion that the rejection server worker pool need a GPU or TPU. This is not the use case, as the rejection server job is not computational intensive. Using the accelerator on this machine would be the waste of the resource and unnecessary cost. Who are as a novice user or novice reader here are participating on this event, I would like to request you to check the documentation, actually TPU documentation, TPU and GPU, and define type of the worker pool and when you should use the reduction server container image and what the facility is, what kind of bit practice you need to follow. Okay, then it will be easy for you to understand. Okay, let us the option C. This option is incorrectly suggested the TPU for the training worker, while TPU are the excellent for certain type of the model. The reduction server strategy is specifically designed to the work with the GPU by default. Additionally, it is incorrect state that the reduction worker pool should be without accelerator, which is correct, but does not mention the correct worker pool for the training code. The correct setup involves using the GPU on the training worker and prioritizing the bandwidth for the reduction server. That you already understand why option is the B is the correct, because this is the first worker pool often the work the actual the model trainings, and they need the powerful machine that GPU to handle the computational intensive work tasks of the training large language model. And third worker pool is the reduction server that will be use the specific reduction server container images. Let us go through with another sample question that will give you the more understanding. You manage a team of the data scientists who use the cloud-based backend system to submit the training job. This system has become very difficult to administer, and you want to use the managed service instead. The data scientists you work with use the many different frameworks, including Keras, Petros, Theons, and Skitlearn and custom library. What should you do? Use a Vertex training to submit a training job using the framework. Option B, configure Kubeflow to run the Google Kubernetes engine and submit a training job through the TF jobs. Or option C, create a library of BM images on the computing engine and publish this image on the centralized repository. Option D, set up a Slum workload manager to receive the job that can schedule to run your cloud infrastructure. So which is very similar that I told you, latest your key point, go through this documentation, find out every single key point overview, then you have and follow my previous session. I explained you when you read the Google Cloud documentation, must be follow the note, each of note. If you follow the each of the note, the each of the after the paragraph, you will find out the main point actually, which options support with which one and which one is not support with other platform. You will find out that it will give you the best understanding to dig up to cover the large documentation in a short time to understanding each of this feature. Let us this is sound like the A, use the Vertex AI training, submit the training job using this framework because you need a managed service, less operational overhead. The Vertex AI training, Vertex AI is a lesser because it is the Google Cloud Management platform. Your team use the many different ML framework like the Keras, Petros, Theon, Scikit-learn, and custom libraries. Current system is hard to administer. The managed service, Google Cloud handle the infrastructure, skilling, and job scheduling, and it was support the multiple framework. As I say, the Keras, Patos, Skitlan, and XBoost, TensorFlow, and custom training jobs, and your team can include the customer library as well into the container and easier administer. No need to maintain the Kubernetes cluster or VM images or slums. That means you can get the everything is the ready from the infrastructure and computational resource services. Yeah, and multi frameworks library you can use using the Bartes training AI. But why other option is the less suitable? Because of this, the queue flow on the GKZ feature, it required the manual cluster management. TFIPs is mostly optimized for TensorFlow, less convenient for the multiple framework. You understand when is the best TF job because it is the mostly optimized for the TensorFlow and it less convenient for the multiple framework. And option C, library for VM images, manually maintenance of the images is operational heavy. If you manage manually the virtual uh, uh, machine, then you need to do too much operational works and it still require the job orchestration. And option D is Scrum Workload Manager is on-premises or cloud VM cluster require the maintenance and scaling effort, not the full managed ML training service. So that means the Vertex AI training is a managed and multi-framework training solution that reduce the administrative overhead and supporting customs library. You need to give the consideration. I loudly mention the keyword. Suppose Vertex AI training is the managed multi-framework training solution that reduce the administrative overhead and support the customer library. Customer library. Let us go through it. Another sample question. You built a custom ML model using the skit-learn training time taking the longer than expected. You decided to mitigate your model to the Vertex AI training and you want to improve the model training time. What should you do? What should you try out to the first? First option A, train your model in a distributed model using the multiple computing engine VMs. Train your model using the Vertex AI training with CPU. Migrate your model to TensorFlow and train it using the Vertex AI training. Train your model using the Vertex AI training with a GPU. You already familiar with the Vertex training AI model training and its capability and its advantages. Let us do the train. Let us the option, the scenario that you have the street gun model and you need to train is taking too long and you need to migrate a Vertex training and you want to improve the training time. So what you need to do? If you do the distribute training with multiple computer VM engine, Skitlearn does not natively support the distributed training across the multiple VMs and it is the complex to implement high operational overhead. The sprint A is not correct because it was take too much time to for the operational head and it does not support the natively support for distributed training. Options B, CPU on the Vertex AI training won't improve the speed the compared to your current environment. CPU performance may be similar or slightly the better. But option C, migrate to the TensorFlow, require the rewriting your model, which is time consuming. No guarantee of the faster training for the same model logic. But option D, Vertex AI training support the custom container and pre-built script container. Using the GPU can significantly accelerate the training for model that support the GPU computation, certain script operation via the library like QML or joblib with the GPU backend, as well as minimum changes are needed to your existing script code if you're using the compatible GPU enable. That is the option D is the correct, and it is very familiar. Using the Vertex AI training job with the CPU, it is the faster, lowest effort way to accelerate your training job of your skit run model. This means option D is the correct. Let us derive one another sample question. Time is too short. Okay, you work for rapid growing social media company. Your team build a TensorFlow recommendation model in an on-premise CPU cluster. The data contains the billion of the historical user event and 1 million of categorical features is noticed as the data increase, the model training time increase. You plan to move the model to the cloud, Google Cloud. You want to use the most scalable approach that use the minimized training time. What should you do? Option A, deploy the training job by using the TPU VMs with the TPU version 3 port slice and use the TPU embedding API. Option B, deploy the training jobs and auto-scaling Google Kubernetes engine the cluster with GPU. Option C, deploy the matrix factorization model training job by using the BigQuery ML. Option D, deploy the training job using the compute engine instance with 100 GPU and use the TFNN embedding lookup API. Let us deploy the training job by using the TPU VMs with the TPU B3 port slice and use the TPU embedding API. TensorFlow recommended model with a billion of event and 1 million of the categories of the feature. Current training on the CPU cluster is the slow. Move to the Google Cloud and maximize the scalability and minimize the training time. So TPU VMs with the TPU B3 port slice provide the highly parallelized compute for large-scale TensorFlow training. Keep this remember. Scale the efficiently to billion of the training example, as well as specifically designed by the large categorical features embedding using the TPU embedding API. TPU embedding API give you the specifically designed for the large categorical feature embeddings, as well as offload to the embedding table computation TPU and drastic reducing memory and computational bottlenecks, as well as scalable and optimized. Handle the billion of event and 100,000 of categorical feature efficiently, much faster than CPU or even the GPU alternative for the specific workload. That's why A is the correct, because A is contains the very high ability, high resource TPU embedding API that was support you the skill and optimize and large categorical features optimization and highly parallelized compute and large scale transfer training as well as supported. Why option is the B, auto-skew and GKG cluster with the CPU. This is very low. Current CPU-based training for such the large scale that is very slow. And auto-scaling helps throughput but does not solve your compute bottleneck for embedding. What is the compute bottlenecks? There is the compute bottleneck. When you calculate computation, the mathematics, the large mathematical calculation at a time, that you need the large memory and operational efficiency. Okay, like you familiar with the site availability, you would say the latency, what the networks availability, you need the proper bandwidth to communicate with your server and everything. It's the same thing. When you calculate the very high level of resource at a time, you need the computational memory so that you can uh, calculate and optimize the computational work so easily with the best performance. And and option C, BigQuery ML matrix the factorization, not designed for highly complex TensorFlow recommendation model, limited customization and scalability for embedding model. So this was not also correct. D, compute engine instance with a 100 GPU plus kf and embedding lookup. Here is one key point you should remember. You are increasing the number of GPU in the computing engine, as well as you give the one of the embedding model there. But it will work when you was the large computation and complex work and large dataset model training. How much will give the support? At what kind of all of this? Suppose uh, model model training, execution, and smoothly running pipeline and computation and operational work will support and manage security configuration, infrastructure manages everything. It will be suitable. No, the GPU may be hit the memory and communication bottleneck, but it was not the correct. That means option A is the best choice. That TPU VMs plus TPU embedding is the most scalable